Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see a different type of DC machine we use as a motors and generators. So basically when it comes to the DC machine can be either a DC generator or it can be either a DC motor. Now the term DC defined is that definitely my input supply will be in a form of a DC. Now we are going to see what is generator do and what is motors, what is the role play of a motors and generators and how they are differentiated with each other. Then we are going to see the basic working principle of a DC machine, and we'll see different type of a DC machine that we have discussed in the previous video, that is how shunt motor will work and how series motor will work. So let's start with the DC generator and DC motor. So types of DC machines. DC machine are basically of two types. They can either DC generator or they can be DC motors. So what is DC generator is? There must be some difference between generator. Generator, that means it will generate something, and motor is nothing but it can be used to move something. So a DC generator is rotated by a prime mover and produces a DC voltage. So basically it is producing a DC voltage because it's a generator. It is generating a DC voltage from the rotation. If you see now here, generator is rotate by prime mover. That means prime mover is a part of machine that is used for the rotation purpose, and depending on the rotation DC voltage is generated. That means in short you are converting some mechanism into energy. That means you are converting mechanical energy to electrical energy. So it converts the mechanical energy into electrical energy, and that is the work of DC generator. A DC motor receives energy from a DC voltage source and rotate at a speed proportional to the applied voltage. Whereas if you see the DC motor, then DC motor receives the DC voltage either which was generated by the DC generator or by the supplied source, and depending on the voltage which it received, its speed will be controlled or speed will be generated at the shaft. That means the mechanism will be controlled by using the voltage source or the electrical source. So here the conversion takes place from electrical energy to mechanical energy. So DC motor is nothing but it will convert the electrical energy into mechanical energy. This is what we called as a DC generator and DC motor. So basically DC generator convert mechanical energy into electrical energy, whereas vice versa DC motor will convert electrical energy into mechanical energy. So here it is given that DC motor, how it is different from DC generator. Now let's see the basic working principle of DC machine. Now before we go for the working principle of a DC machine, we should know what are the important parts are there present in the DC machine. So in the previous video we have talked about the windings. We have a armature winding, we have a field winding. So what is the important part of this winding is windings in a DC machine. So in any DC machine, either it is a motor or a generator, there are two windings. One is field winding and the second one is a armature winding. Now field winding is stationary. Now we have a two windings in a DC motor or the DC machine, whether it is a DC motor or it is a DC generator. So whenever it is a field winding, it is a constant, it is a fixed winding, whereas the armature winding is always the movable winding. So field winding is a stationary, it do not rotate, and armature winding is a movable winding. So basically this will move and it will generate the speed and torque whatever is required as per the application. Now let's see how the energy conversion in generators and motors takes place. So this diagram shows the energy conversion in a generator. So basically generators are nothing but they convert the mechanical energy into electrical energy. So basically DC voltage will be produced by using the DC generator. So this is the generator where there is a prime mover. That prime mover will move and it generate the mechanical energy. That mechanical energy which will be developed by movement of the prime mover will be considered as an input for the DC generator. Now this block represents the DC generator which is receiving the mechanical energy as an input. Now this mechanical energy, the DC generator will generate a DC voltage across the load. So here you can see there is a electrical output energy is given at the output of a DC generator. So basically prime mover is giving you some mechanical mechanism and that will be considered as an input to the DC generator, and according to this input DC generator will produce an output as a DC voltage. So this particular device will convert my mechanical energy into electrical energy. Secondly, we have energy conversion in motors. So here you can see DC motors, the input voltage will be electrical input. So basically it will receive input as a DC voltage from the input source. So from the input source electrical input is provided, which is nothing but the positive and negative terminals are connected over here. So this is the positive voltage supply is provided to the DC motor, and at the output you can see the shaft is connected or the load is connected. So this is called as a shaft. So once it will get the electrical energy as a source, this shaft will start rotating in a clockwise manner. When this shaft will rotate, the mechanical load will be driven by this energy. So basically here from electrical energy, we are converting this electrical energy into mechanical form of energy. So this is how the conversion of energy takes place in DC machine. Now let's see what is the principle of operation of a DC motor. When current carrying conductor is placed in a magnetic field, it experiences a force. Now whenever there is a winding, there is always a stator and a rotor. When we talk about a motor, we have already discussed this particular topic where we have discussed about what is the stator and what is the rotor and what is the major part of the stator and rotor in the motor. And also we have two different types of windings. So there is always a current carrying conductor present, and if you keep that current carrying conductor in a magnetic field produced in the motor, in the winding, then this will experience a force. Now in case of a DC motor, the magnetic field is developed by the field current, that is the current flowing in the field winding. So there will be current will flow in a field winding because of the magnetic field present over there, and it will experience some kind of force. The armature winding is connected to an external DC source, hence it plays the role of the current carrying conductor placed in the magnetic field. Due to the force exerted on it, when placed in the magnetic field, it starts rotating. We have two different parts, that is a stator and rotor. So basically stator will act as the current carrying field or the conducting field, and the magnetic field produced in the winding will exert the force on the rotor, and rotor will start rotating because armature windings are the movable windings, whereas the field winding is the stationary. So stator will be stationary and rotor will be a moving part. So whenever there is a force developed on rotor, rotor will start rotating, and this is how the torque can be developed. So basically this motor will start rotating, it will start running. That is how the working principle of motor. Now we have seen what is the working principle of a DC motor and how this generation of electrical to mechanical and mechanical to electrical takes place. Now we have discussed the different types of a DC motors depending on the type of connection it has with field winding and armature winding. If the field and armature winding is connected together in a parallel manner, then it is called as a DC shunt motor. Then second type we have is if their connection is in a series, then it is called as a series motor. And we have a compound motor as well. So we will see the one by one how the shunt motor can be placed, how the series motor can be connected. So here we have a diagram which represents the DC shunt motor. Shunt is nothing but parallel connection. So here you can see supply voltage is given, the plus is connected over here and negative of the terminal voltage is connected over here. RSH is nothing but resistance of the shunt field winding, and RA represents the resistance of armature field winding, and for armature field the load is connected which is to be driven by the energy which will be produced at the armature. So basically this area is nothing but the field area and this area is the armature area. So if I draw, so basically this is nothing but my field and this is armature. So you can see your field winding and armature winding are both connected in a parallel manner. So parallel combination of the two windings is connected across a common DC power supply. The DC power supply is provided that is common for armature winding as well as field winding. So here field winding is stationary and armature winding is rotating, or it can be a movable. So the resistances will play a major role. Now due to the combination of a parallel connection of a field winding and armature winding, this is called as a DC shunt motor. Now let's see how the current, this IA represents the current of the armature winding. This is the armature current flowing through the armature. RA represents the resistance of a armature, and ISH is a current flowing through the field winding, where I is the total current. So I can be distributed to the field and armature. So I can be represented by IA plus ISH. Now let's see what will be the relation between the supply voltage and the current produced because of the supply voltage in armature and field. So here we have a current and voltage relation. I can be represented as the total current flowing through the circuit is equal to the current flowing through the armature winding plus the current flowing through the field winding, which is represented by IA and ISH respectively. So here I is a total current drawn from the voltage source, IA is a armature current and ISH is a field current. So now field current, that is ISH, can be represented by V divided by RSH. You can see in the diagram that this is the voltage supply to this. If you want to find out what is the current flowing through this, so ISH can be calculated as a voltage across this point divided by this resistance will give you the value of a current flowing through this branch. So here the voltage is applied is V, since there is no parameter connected in this branch. At this point my voltage is equal to V, so I can write ISH is equal to V divided by RSH, that is the resistance present in this branch. Since ISH is the V divided by RSH, supply voltage can be given by V is equal to voltage across the armature, that is also equal to voltage across the field, because the same voltage is provided for the armature and field. So voltage as a supply voltage will be equally distributed to the field winding and armature winding because they are connected in a parallel manner. So you can write EB is nothing but the flux produced at the armature winding because of the voltage and current present over there, plus it is the combination, that is the voltage across the armature winding, and voltage across the armature winding can be written as IA into RA, where IA represents the armature current and RA represents the resistance of the armature, plus V brush. Now we are talking about the motors which is having the brushes. So when we have a brushes, there is always voltage present across the brushes. So we have to consider the voltage present across the brushes. So here in this equation also, along with the EMF and voltage across the armature, we have considered the voltage across the brushes, but this value will be negligible, so it can be neglected. So at the end you will get voltage is equal to, it is ISH into RSH. So now in this process the flux which will be produced remains constant because field current is responsible for the generation of a flux. Now whatever current which will be produced across the field winding, that is because of the connected source voltage, that is V, this current across the field winding will produce the flux, and this flux will remain constant whenever it is a DC shunt motor. because the flux is directly proportional to the current flowing through the field winding. So shunt motor is also called as the constant flux motor because the flux is completely depend on the field current. Since the field is stationary, there will be no change in a current. So if there is no change in current, there will be no change in the flux because flux is completely dependent on current. Since we all know that field is stationary, current will be constant, and if current is constant, flux will be constant. So this DC shunt motor is also called as a constant flux motor. Now after this we will see how the series DC motor will work. So this is the simple diagram of a DC series motor. Here you can see this part represent the field winding and this part represent the armature winding, and here the field winding and armature winding are both connected in a series where the supply voltage is given, that is the same. So total current flowing through the circuit will be the current flowing through the field winding as well as the current flowing through the armature winding. That means you can see the ISH, that is the current flowing through field winding, is equal to IA is equal to I. Now here armature and field windings are connected in a series with each other, so flux does not remain constant, because if you change the voltage across the device, voltage across the circuit, this total current will change. If this total current will change, also there is an inductor connected, that means the field current will also change with the change in a current. That means if all the currents are same, then this current will not remain constant for a different conditions of a supplied voltage. So here if flux is directly proportional to current, this current can be any current because the same current is flowing through the circuit, then this flux will also not remain constant. So DC series motor, if flux does not remain constant. So that is the basic difference between DC shunt and DC series motor. We have seen that in DC shunt the flux will be constant, and DC series there will be no constant flux remain present. Now we have a different types of a compound motors also, but we will concentrate more on a DC shunt and DC series only. I hope you have understood how the different types of DC machine work. Thank you for watching this video. Stay tuned to Ekeeda. Do subscribe Ekeeda. Thank you so much.